Namaste everyone. In this video we will be doing the derivation for perpendicular axis theorem. This theorem gives us a relation between Ix, Iy and Iz. Let us first understand what these quantities are. So let us say we have an irregular area of total area dA. Let us assume a small elemental area inside this of area dA. Let us say the distance of this elemental area from y-axis is x, and the distance of the same elemental area from x-axis is y. Then Ix will be defined as integration of y square dA. Iy is defined as integration of x square dA, and Iz is defined as integration of the straight distance r from the z-axis. So it is defined as integration of r square dA. So the Iz is also sometimes written as z and is called as polar moment of inertia. Let us start with the formula for Iz, the polar moment of inertia. Now according to definition, that's equal to integration r square dA, and if we carefully observe this triangle, we see that there is a right angle here, and x and y are the two sides of the triangle, r being the hypotenuse. So we get r square equals x square plus y square according to Pythagoras theorem. Substituting that in the equation, we get Iz value as integration x square plus y square into dA. When we open the brackets, we get x square dA plus integration y square dA. Now we know by definitions of Ix and Iy that this term is equal to Ix and this term here is equal to Iy. Therefore, perpendicular axis theorem gives the relation between Iz, Ix and Iy as it is written here.